Hey guys, this is Mainak, your civil bro. So in the previous lecture on the course, you had seen that we had made a plan, and I made some modifications to the plan, cap file, the PDF file at least. I'll just share it with you so that you can practice it along. So the PDF I'll share and the link I'll give in the description so that you can just make sure to have a good practice. So this is the this CAD file of this plan, and you can see this is the second floor, the first floor, and the ground floor. So these three floors are there. Okay, 1726. This is there, and this will also be 1726, and also the same. So 1726 square feet, ground floor and first floor, and sorry, first floor and second floor, and the ground floor we have 1522.5 square feet. So this is the plan for the ground floor and the first floor. Now our objective one is complete in this live project, that we have finalized the plan from the client, and as you can see in the plan also, we have made a few changes. And now in the architectural plan, we can add various things, like we can add the door window schedule like this, and we can add the furniture components, but that we'll do later. Now let's focus on the structural design part, because this much plan is okay for the execution part, and furniture layout, and providing the door window schedule, that I'll just show you later in another video, in another lecture. But today we'll see how to just do this in STAAD.Pro. So for doing this in STAAD.Pro, first of all, the STAAD.Pro does it, the unit is in meter and Newton, so SI units. So to convert this into meter, we can just directly convert it, or you can use the align command to convert it into your meter. So let's convert it into meter, and then we'll just design in STAAD.Pro, and if time permits, then we'll also see the design in Technical Structural Designer as well. We'll compare the results, and then if time permits again, we'll do the same design in ETABS as well. So this earlier part of the course will be the same, and the live project will be the same, and then we can do in three different softwares. That is our motive to do, and we'll complete the design in each of the software. And after completing STAAD.Pro, I'll do the drawing part as well. And the drawing part. After doing the drawing part, and share the output of the drawing part as well, so that you can get some idea. So let's get started. So first of all, to convert it into meter, let me what I'll do. I'll just make a new file in AutoCAD, and here first of all UN enter I'll do, and decimal in meter, since it is, so then 000 I'll need, and precision, and the unit is obviously meter, right? Meter, and click on OK. And let me set the text and dimension also, because that might be required here. So I'll just go new text here, T100, and I don't matter the font here, though I'll select Times New Roman here, and the height. So height is 150 mm. For 150 mm in meter is 0.15 meter if I consider. So I'll just click on apply and set current here, and the dimensions also. I'll take forward a new dimension here, uh, D100, and when I consider the D100, then we'll just go to primary units, and this will be obviously decimal, and 000 is this here over the dimension line without leader, and text, we'll select the text which you have made, align with dimension line. Symbols and arrows, this is important. Arrow size I'll keep as 0.15, or you can keep it less also, 0.14 also. So considering 100 scale, just click on OK, and after clicking on OK, just click on set current, and dimensions are good. And if we need leaders, then we'll set leaders as well, because I think there is one leader in the thing. So leaders, if we need L100, and L is in capital, so L100, start standard, continue, and only need to set the arrowhead 0.15, and then this content, in the content we have this text style as the 300. Okay, and then set current and close. So units and all are set, and we are good to go. So here this drawing, will just open the earlier drawing which you made in fit wala drawing. So this is 34 feet, and I'll just use the calculator in front of you so that you can have an idea here the conversion process. So 34 feet, what will do 34 divided by 3.28, which will exactly convert it into meter. So meter, it is 10.365 we'll take three places of decimal. So it will be 10.366, these 34 feet, 10.366 in meters. So I will do here 10 point, do here 10.366 in meters, and this linear dimension will take, and we'll see it is okay, it is something wrong here. 10 should be 10.366. Okay, let's do it again. So meter here 10.366, enter, and then we'll check the dimension now. So it's 10.366 as we wanted here. And if you want little bit more precision, because I am thinking like this is 10.366, and if you could have another more precision, then you could go with 10.3658, then that would be better, it would be slightly better. So I'm doing UN enter once again, and precision I'm just doing one digit further and click on OK, and then I'm closing this. And what is my value here? 10.3658, right? 3658. So we'll do here 10.3658, and in the decimals, we just take this here. So it is 10.3658. Now 4 places of accuracy, decimal accuracy we have taken, so no problem in that. And then we have this all the other things which we have here. We can convert this easily. So what we'll do, we'll just select the entire thing first. The entire thing, will make sure we select this entire thing. We'll copy here, and we'll lose some of the things which we don't need actually. First of all, select one text and right click, and then select go and do select similar. So then in the entire drawing, shift and deselect this, only these things will be selected, and then delete. Same with the dimensions. Select this dimension here, right click, and then click on select similar. And after that, just zoom out and shift select, that will deselect the entire thing, and then deselect this thing. This one we don't need. Okay, and this also, this thing we don't need here. So these are the things which we actually don't need here. And you can also make the beam column plan here approximately, but right now just we'll just take it to the next step. So this also we don't need, this one, and just start from this staircase, start from here, staircase representation, this will just close. Okay, so most of the things which we don't need, we have just deleted them, and we'll see what we can do here once we take it to the other part. And same we have to do it with the first floor and second floor. The first floor and second floor plan, as you can see, it is the first floor plan is similar to the ground floor plan, only the two balconies are there which are extending in both the directions. And this plan is pretty much similar. And the second floor plan, it's different, right? It's the arrangement, internal arrangement of the second floor plan is different. So what we'll do, we'll just copy the second floor plan here, and we'll also just do this. And same will go with the first floor plan as well. Just first floor plan, select here, and this. It's better that we keep the second floor plan than this side. So it will be ground first and then second, all in the serial order. So here, let's just select the dimensions here, and then right click, and then select similar. Select this, right click, and then select. Where is the select similar? This select similar, and then press shift, and then deselect this entire thing. So once this is done, we'll just click on delete. So this is deleted, and we have this ground first and second. So we have this just the staircase portion in the presentations, they are not required now, so we can get rid of them. And so this is the ground first and the second. So now we can just copy this all these three things in the meter file. Just Ctrl+C, and then go to the drawing here, and then Control plus B, specify the insertion point. So you can see Control plus A that it has been inserted here. So the size is pretty much large, and this is the size which where it needs to be aligned. We'll just move it up a bit. So we'll align all the three drawings at once. This is this we know. So what we do, we just select all three drawings here and use the command AL enter, and source point, first source point, the left position, this one, and left position this one, and right position this one, and right position this one, the one which we take which have taken the value, and then press enter, and scale of this based on alignment points, and click on yes. uh, Delete the thing which is not required now. So entire thing is now scaled, and you can see the other things have also been scaled. For example, the column is supposed to be 300, a little bit size difference is there, so it's okay. And down thing is that the entire thing has been aligned accordingly. So you can also see the conversion of the 44 feet, and if you see in this particular drawing, this side is 44 feet, and if you convert this 44 feet here, 44 divided by divided by 3.28, it will be 13.4146. Up to four places we take, it will be 13.4146. So if we just look into this drawing also, and let's check whether our conversion is accurate or not. And this you can see our result 13.4146, and this you can see 13.4. So the conversion, you can see it's accurate, or this would be accurate for all the three drawings. So once we have known that this is accurate, the next thing which we need to do is make the beam column plan, because in STAAD.Pro, when we see the beam column plan, we need the exact location of the beams and columns. So since we have three different types of drawings in three different parts, so we'll not import the CAD file. We can do import the CAD file, and then we can do the first floor plan separately. But we'll make the this nodes, and then we'll proceed. So there is no problem in that. First of all, let us make our beam column plan here. So first of all, let me just delete this, right? So the beam will be, this is a solid line here. So the beam will be a 250 mm beam, which will take for the plinth, obviously 250 mm beams take, and this will be 250 mm. Sorry, it will be means in meter. It is, sorry, I forgot the meter. 0.25 it will be. So 0.25 from here, it the size. And for this also, you can see the beam location will be here because there is a beam. And let's make one solid line here. That will be better. Start from here and take it up to here, and again offset of 0.25. So this is the two main beams which you have drawn, and the third main beam which I want to draw here. I'll just copy it from this main beams from here. Copy and paste. Move it. So these things are done, and here also, obviously, you'll need a main beam here along this direction. So offset. This is done here. Along this also, there will be a main beam, and just select the things because we don't want any overlaps and all, and delete them. And you had noticed that this was along this line, left line of this staircase. So beam from here, right, and then 250 mm. So this is a beam here, and main beam, and the next horizontal main beam, which will be from this one and this one. But let's do this one first. Okay, this one and this one. Let's do it. Let's take one beam here and offset of 250. This beam has been done, and here this for this particular portion here we will have another beam here. Let's have a beam, this one. Let's start from here and do up to this much, and this one also let's delete. Offset 250, enter, and here we'll just take this, select EX center, and this one is on the same line. So what we'll do is just delete them both and delete, just change the line here and join it. You select this and EX center, join this, and offset of 250 mm, and here just press Ctrl+C to trace a few steps. Okay, it was along the outer side, right side. I'll just give the offset. Okay, Ctrl+Y to revert back to what we have done. Okay, so first of all, I can extend this and then offset of 250 to here. So this is our plain beam structure for the toilet actually. So this will be the same in this direction as well. If it is, this, let us just delete this, and I'll just extend this just to be sure. And this also I'll delete. Let's see if this fits there. Copy. Okay, just take it up to this and we'll rotate this now. Ortho is on. So rotate it successfully, and then we need to paste it. So yes, it's done here. Now for this particular wall, we have to give the offset. So we'll start from here. Offset, this will be along the right side of your screen. You should remember that. Let me select this and press J, enter, join, and then O 250 like this. So once this is done, this beam is done, then we can select this and select EX, enter, and then join this. Okay, so then we'll select this and we'll select this and delete. Then we can select both of them and join them, and then O, enter, and then give a beam here. So you can see in the drawing also the beam was on top. So we're good to go. So we have done for the toilet and all. Let's select and delete this. Toilet portion has been done. This one has been done, and this one, if you want, just trim the things which are not required for you. Okay. This is an intersection, so make it look like an intersection. And this is also okay. This is not required, I think. Yeah. come up with this much. And this beam also, if we are talking here, this will not be required, and this will also not be required. And this two can join, right? This two can join, and this one and this one can join, and this two will not be required for now. Okay, what have I done? I think right too much. Yeah, this is okay. Only thing we need to do, we need to make an intersection here because the main beam will always stay. Some mistake. Now we're good. Yeah, now we're good. Just the intersection. Make sure to. Okay. Now we're good here with all the beams here. We're good. And the toilet is there. Remember, everything will be along the inside in this case. So offset of 250 inside. Next and extend. We need to connect two secondary beams cannot be there, so we need to connect them. Like this. And the staircase will start from here. Obviously, we'll need a beam here. So a beam will connect to this primary beam, and first of all, I'll just extend this beam here up to this portion. Okay, and then offset of 250. Sorry, it will be 0.25 obviously, and then this EX center, and then extend this, and then trim this. Okay. Once this is done, just select this and delete, and then join this, and then select this, extend, select this, EX center, and then join this, and then TR enter, and then trim this. Okay, and then there will be another beam here, but in the plinth level it will not be there. It will be in the mid landing portion. So in the plinth level, you don't need for this. This will be in the mid landing portion. This beam will be there. We need to put the coordinates separately, and we'll measure and put the coordinates separately for the mid landing beam. So that will be a separate case. Okay, when we will be providing the staircase, we have to do that. So this is pretty much it. The ground floor plan is ready, and then there are various things we need to do for the other things to be proceeded. Now we need to have the center line here, and let's make a new layer here, and we call this center line CL, and let's give this 252, and line type. Let's load a dashed line type. Um, okay. 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 Just close it. Let's take a center line layer and take a line here like this, normal simple line. Select this and extend this, and then copy. Then we take this and this. So once this is done, just take this, copy, So this is done here, and you can see all the center lines have been done. And after that, these are the main column center lines have been done. And after that, we need to also do the things for the secondary beams as well. Okay, positions where we build the secondary beams, you need to find the center lines of that and make the center lines of those things as well. So let's do it, right? Some things which will help us to find the center lines, we will just use them. Later, I will lead them. So center lines of the secondary columns that we find to help them in the AutoCAD. And any other secondary beams which we have, this one we have. The one over here. So let's see, select this, copy, and the vertical ones. Once this is done, let's take a rectangle here, select and TR, enter. So this is done here, and you have the center line now. Now you can delete these things which you don't need. I could have put in a layer, then one click could have deleted them all. Okay, this portion I think this is remaining, the center line. Select this, copy, done. Now I can delete. So like this, the center line has been made. You can see the time taken for this. If I had not been a little bit fast, but this much time will take for making the center line. And after you make the center line, then you need to have the coordinates. For the coordinates, you need the dimensions, linear dimensions. So once this is 0, 0. So take the dimensions from here. If there is nothing here, actually. These are the horizontal dimensions, and let's go for the vertical dimensions as well. This will be along the y-axis. In AutoCAD, this is actually the z-axis. Sorry, in STAAD.Pro. STAAD.Pro you'll find X and Z. In AutoCAD there is X and Y, so that's the difference. So it's 13 point. All these dimensions we have taken, and now we need the coordinate of each and every point here. So we'll see how to we write the coordinates here. So what we'll do, we'll write the coordinate here itself, and then we'll just use the Excel file. When you have learned everything, you can just do it on yourself. So all the intersections will need the coordinates for that. Okay. So I use here multi-line text here to write the coordinates. And the first coordinate, let me write here 0, comma, in brackets 0, comma 0. This is the first node. And better I just have a layer to denote the coordinates. These are the coordinates which I'll use the stat, and obviously I'll need to better if I give it a color, say green. Make this the current dimension. Okay. So the next coordinate will be 3.9634. This will be 3.9634, 3.9634, comma 0. This will be the next coordinate. So like this, we have to write all the coordinates. After just writing one or two more this line, and I'll just fast forward the video because otherwise it will be very boring. Okay. Copy. And this will be 6.7073. And 0.0609. So when you'll go to the next step, what we'll do, this will be x will be 0 and 0, comma 3.3262. Okay. Now these two toilets were in the same line, so I think one of them has an error, right? Either this one or this one. Let me just check here. So the beam is at 7 feet. 7 divided by. Okay, I can check from here itself the distance. So here, if I give let's say a 0.25 offset, what is the distance, inner one distance from here, inner to inner? It is 2.0122. So 2.0122. I think this is correct, and this one is wrong actually. So I'll just select this and this, and copy this, and do it here like this. Like this, select this, enter, select this, and then we're good to go. Right. Let me check this distance in the next of the other distance. 1.00965. This is also 1.0965. So this is good, and this is a good thing. And we will continue. in the next step. Okay, this is 2.2337. So this will copy, and this will be 2.337, and 2.2337, right? So this 2.2337, and this thing will remain the same for this as well. So this is the same, and the next one, just copy. Next one, for the next one, x coordinate, we already have this. Only the z coordinate will change, and we know what it is. I'll just simply copy it and then paste it. This one also, I'll just copy this to the next point, and then I'll just copy this and paste it here, right? And then you have this 0 0, this will change this one. So this one is 0 comma, now it will be 4.7002. It is 4.7002, and then copy. This is also 4.7002. This is also, okay, I can copy this one, right? Place it here, double click, and see this, copy this, and then paste it. Similarly with this one, you can simply copy this, and this particular thing, the y coordinate, the same, I can paste it here like this. This one, this coordinate also needs to be given. So let's see the length here. This is 5.4603. So only copy this. Okay, we have some room, we can move this one. So it will be 5.4603. So just do this. Select this 5.4603, and select this, enter, and do this here, and this one, okay, and select this, copy, and do it up to this much, and here just select this, copy, and then paste. So this is 10.0609, and this is done. So this line is done. So going for the next coordinate here. So this will be the length, you can see here, and this one. This one is 7.442. So just make this 7.442, and this one, x coordinate is the same. So just copy it here, and 7.442, already know this one. Copy this, Ctrl + C, double click, and then Ctrl + V, and this. So this one, let me just write of some space, and we'll just copy this and just move it a little bit right because we need space here. And so we put to copy this one, we paste it here, and this one we'll copy, and paste it right. So I'm going to go for 2, and this one copy, click and then paste. Then copy this one, the x coordinate. You'll see here 7.8 to 70. 7.8 to 70. So we have selected all this, right? All these are selected, and then we'll move it to the next point. Only this coordinate will be 10.010121. So in the one you can write 10.0121, right? 10.0121, you have written this 10.0121. So no, it's not 10.01, this one actually. My bad, 8.8160. So it is 8.8160. This one 8.8160. So here just write 8.8160 and copy this, and then you'll paste it in all the z coordinates. Okay. So you can see we missed one coordinate here. This should have been done. So no problem. We'll just copy this, and this one we'll just do it here. And for this particular column, we'll just see the requirement for this one. So I'll take a linear dimension here from here to here, and this is the dimension here actually. This is in 0. So it is 7.3170, the x coordinate 7.3170. So we'll just write here. First of all, we'll just copy here. Turn off the ortho, and that will be better representation, I think. Okay. So that is 7.3170. Just make it edited 7.3170. So that thing is done. And after the editing is done, I think every thing in the next row, the x coordinate is the same. Okay. X coordinate is the same. Only difference is the z coordinate, and the z coordinate is 10.0121. So just make this coordinate here 10.0121, and okay, I forgot to copy this. Select this and Ctrl+C. Select this and Ctrl+V. Select this and Ctrl+V. Select this and Ctrl+V. Select this and Ctrl+V. Select this and Control plus V. So next we have this. Actually, this is also a main beam. We can give the beam here, but we'll give it in the next level. This one is not required. Select this, and select this. Copy and paste it here. The x coordinate, sorry, the z coordinate 13.1097. So just write here 13.1097 and copy, paste. Paste. Paste it here. Okay, actually, we need the dimension for this column, the coordinate for this column as well. This column is along this line actually. So you could have joined this. So if I join this, then this will get reduced, right? So since it's the main column, what I'll do, I'll join this. I don't have anything here in the top floor. It is along this right side, so I'll just join it along the right side as well. But then there will be two beams, so I'll avoid this beam here. Sometimes some beams can be avoided if it's less than 3 meters. Take the turn on the ortho and give an offset of 250 mm, 0.25 meter, that is okay. And this one we will just do up to this much. And this one also will go up to this much. And this one we'll ignore, like these two, and J enter, and ignore this because already there are many beams nearby, so we'll ignore this. It can be done if it's less than 3 meters, it can be done. So you should know that. So now we have completed the the coordinates of the ground floor plan. We'll stop this lecture here, and in the next lecture we'll also do the coordinates of these remaining things. So everything is done actually. Only the balcony part we need to give the coordinates. Other coordinates are the same. Only one extra element will be added. So we'll do all this for the first floor. And the second floor, the plan is different, so the coordinates will be different. And also the if we consider AutoCAD, then the Z coordinate and Z coordinate will be different. So if we consider the STAAD.Pro, the Y coordinate will be different. So we'll learn about that. Make sure you do up to this much. I'll upload the video, and along with I'll also upload the PDF of all three plans so that you can practice. Thanks. Keep learning. Like the video. Bye bye.